Hi all, Audrey here. So let's do group work 1. The first question says, explain in your own words what is meant by the equation limit as x approaches 8, g of x equals 4. So here we need to explain what this means to someone that might not know what it means. So what this is saying is not that at the x value 8, g takes the y value 4, but that if we look at values that are close to 8, at values that are close to 8, so in other words, I would be looking at like 7.9, 7.999, 7.99999, and 8.1, 8.01, 8.0001. So values that are really, really, really close to 8 on the left and the right side. If we look at those values, we can see that as we get closer to 8, the y values are getting closer and closer to 4. X equals 8, the y values. So in other words, we're saying that we would expect for the y value to be 4 when x equals 8, but it might not be. We don't know. It's just our expectation. This may or may not be true. So these are my words. It's asking you to explain in your own words. Clearly your words might be a little bit different than mine, probably will be a little bit different than mine. I'm just saying, we look at the left and right side, we kind of follow the graph. We would expect for 4 to happen. Maybe it does, maybe it doesn't. So then B says, is it possible that the limit as x approaches 8 of f of x equals 4, and at the same time f of 8 equals 3? Well, if we look at my words up there, we just said we would expect for it to equal 8. I mean, for y to equal 4, but it might not. For example, maybe it equals 3. So here it says, if so, sketch a graph that satisfies both conditions, and if not, explain why not. So here, I'm going to start off by sketching a graph that just represents the limit as x approaches 8 equals to 4. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Now we know that limits don't tell me what's happening at that value, but around it. So when I'm about writing a limit that's not a one-sided limit, I have to draw little tails on both sides. So that limit would be something like this, where I have maybe a hole there and tails going out both sides. But then f of 8 equals 3, that would be my closed dot right here at 3. So that closed dot is at 3, whereas that open dot is at 4. Now, it doesn't matter what I do with these because I don't have any other information. So all that has to be true is that. But notice that the tails are going to 4 and leaving from 4. Something like this, saying, hey, look, I'm going to 4 and leaving from 3 and having the closed dot, this does not work because the left and right sides are different. In this case, the limit as x approaches 8 of f of x does not exist. I cannot create an expectation because the left and the right are different. Okay, so our next question here is a graph, and we want to evaluate the limits using the graph. So I'm starting at -3. So here is my -3, and I want to know what happens as I approach -3 from the left. So that means I'm looking at the left side of -3. I go up to the graph, and I follow that graph back towards -3. And what happens when I get there? Well, it looks like 1, 2, 3, 4 would be happening. So that limit is 4. And then on the right side, if I were to do the same thing, So this was -3 from the left. -3 from the right would be over here on the right side of the graph. I follow it back to -3 and check it out. That's 4 as well. Now, since both of those sides were the same, that means I can create a clear expectation. My clear expectation is 4. Does that 4 happen? No, it does not. What happens instead? Nothing. So the reality that h of -3 does not exist. Now I can do the same thing with 0. On the left side of 0, I see that I'm getting closer to 1. On the right side of 0, if I follow that graph, it seems to be going towards -1. Those are different. The left and right are not the same. I cannot develop a clear expectation of what's going on. So then this does not exist. So that said, what actually happens? Well, we can see that our closed dot is at 1. What is the y value when x equals 0? It's 1. So h of 0 is equal to 1. Now let's look at 2. Notice this limit doesn't say left or right. So when I'm at 2, I need to look at both the left side and the right side. If you're not told a side, that means you have to consider both together. Both are getting closer and closer to the same place. That same place is 2. So this limit is equal to 2. But at 2, there is no reality. Nothing actually happens. So we would write does not exist. Now 5. So 5 from the left, I'm going to the left side of 5. I'm finding the graph. I'm following that graph. And we can see that the y values are just getting smaller and smaller and smaller. And they're going to keep doing that forever and ever. So that means we have a negative infinity there. 5 from the right, though, if I go to the right side of 5 here, so that's my 5 from the left. 5 from the right, I follow it back towards 5. The y value seems to be 3. So there you go. We've just evaluated the limits from the graph. The next question, though, is also about this graph. And it tells me to list and name the discontinuities and to justify my answer. So remember, a discontinuity occurs when the expectation does not equal to the reality, or when there is no expectation. Another way to think about it is when I'm drawing the graph, where do I have to pick up my pen? So the first place that I have to pick up my pen here is x is equal to -3. So remember, discontinuities, we always list them with their x values. Now I want to name this discontinuity, and I need to justify that why I've named it that. So if I look here, I can see that the limit as x approaches -3 of f of x, which we said was equal to 4, does not equal to f of -3, which does not exist. So in this case, we have a removable discontinuity. Now the next place that I would have to pick up my pen and keep drawing, I get to x is equal to 0. And what I can see here is that on the left side, as I approach 0 from the left, we said that that is equal, this is an h, not an f, my bad. So h of x, h of x, h of -3. So the limit as x approaches 0, h of x, as we approach from the left, we saw it was equal to 1. Which does not equal to the value we get when we approach from the right, which we said was equal to -1. So when we have that gap in between them, we're going to one place and then starting out from a different place, we call that a jump discontinuity. So this is our jump discontinuity. Next place I have to pick up my pen is x is equal to 2. And that is, again, a removable discontinuity. For the same reason that x equals -3 was removable. Because if I look at the limit as x approaches 2 of h of x, we said that is equal to 2, which does not equal to h of 2, because h of 2 does not exist. Now I have one last discontinuity here. And that is x is equal to 5. Because at x is equal to 5, I have a vertical asymptote. So we call that, not a vertical, an infinite discontinuity. Infinite discontinuities exist when we have vertical asymptotes. So how would I justify that? I would justify that by saying because the limit as x approaches 5 from the left of h of x is going to negative infinity. In other words, one of our limits is infinite. Left one, right one, maybe both of them. So anyway, this would be how we evaluate those discontinuities from a graph. And now we have reached the limit portion of this group work. So for A, we want to evaluate the limits using methods learned in class. We want to evaluate the limit as x approaches 5 of 3x squared minus 14x minus 5 over x cubed minus 5x squared plus 3x minus 15. We know that the first step with limits should always be plug in and see what you get. So I'm going to plug in 5 to my x values, and I see that I will get a 0 over 0, which is an indeterminate form that tells me to do something else. This something else I want to do is I plugged in 5 and got 0, so I know that x minus 5 is a factor. My goal, therefore, is going to be to factor these things and get rid of the x minus 5 that shows up. So since we're supposed to use methods learned in class, we're going to use in the numerator the fact that we know that x minus 5 is a factor, and ask ourselves what the other factor would have to be. So I don't have to think about that negative 14x because I know x minus 5 is a factor. I just have to think about what would I multiply x by to get 3x squared? And the answer is 3x. When I look at this, I'm like, x times 3x is equal to 3x squared. Awesome. So another way of thinking of that is x times question mark is equal to 3x squared. So question mark is equal to 3x if I divide both sides by x. Now I'm doing the same thing. We needed that 3x squared. I also need that negative 5. So I'm like negative 5 times question mark is equal to negative 5. So I took the x, now I'm dealing with that negative 5. So in this case, my question mark is equal to a positive 1. So my other factor must be 3x plus 1. Now in the denominator, I'm factoring x cubed minus 5x squared plus 3x minus 15. And this I cannot factor in the same way because it's a cubic polynomial. I'm going to need to factor this by grouping. So I'm looking for the greatest common factor of each of my separate groups here. And it's really easy to screw up the notation when you're factoring by grouping. I noticed a lot of you did that, so be very careful. When I factor out the x squared, I have x minus 5 left. Then I have plus, not just a 3. The 3 comes after a plus sign. What's left over is x minus 5. Now I can factor that x minus 5 out and have x squared plus 3 left. So that is my new denominator, x minus 5, x squared plus 3. We can cancel those x minus 5s out, and we'll have the limit as x approaches 5 of 3x plus 1 over x squared plus 3. And now I can plug in 5 again because I canceled out my x minus 5s, and I get 16 over 25 plus 3, which is 16 over 28, which is 4 over 7. And that is my final answer here. So 16 over 28, if we divide 16 by 4, we get 4. If we divide 28 by 4, we get 7. So it reduces to 4 over 7. Now, next. So in the next question, it was different depending on if you're in my enhanced class or my regular class. I'm going to do both problems because they're both really useful, and so that way you guys can kind of see what's happening with both of them. So the first thing is that when I have the limit as x approaches 2 of root 2x plus 5 minus 9 over 16 minus 4x squared, when I plug in root 2x plus 5, I end up with the square root of 9 minus 9 over 0, which is 3 minus 9 over 0, which is negative 6 over 0. So anyway, plugging in therefore results in negative 6 over 0, not 0 over 0. So even though this looks like a rationalization problem, it's not. Plugging in gives me a constant over 0, not a 0 over 0. So at the time when you had this, your answer would have just been, I don't know how to do this yet. We haven't learned the method for this. And that was the answer that was expected. This didn't give me 0 over 0. We haven't learned how to deal with this yet. But in the meantime, we have learned how to deal with this. And we know that this negative 6 over 0 is going to give us either a negative infinity, a positive infinity, or a does not exist. And so we just have to figure out which one of those things it is. So I'm going to do that. This is not a one-sided limit. So I need to evaluate 2 from the left and 2 from the right. So I'm going to plug in values that are close to 2 on the left side and the right side, but not 2. So we want them to be super, super close. And when I plug them in, I'm really just checking for signs. So if I have 2 from the left here, I have the square root of 2 times 1.9 plus 5 minus 9 over 16 minus 4 times 1.9 squared. So on the top, that gives me a positive value. And then on the bottom, that's going to give me a positive value as well. So this is positive. I lied. Sorry about that. That's definitely not a positive value. That's a negative value on top. So we have a negative value up here. So this gives me a negative value there. So on the left side, we have it's negative, which FYI means that the limit as x approaches 2 from the left of this function is going to negative infinity. And now if I do 2 on the right side, then I'm plugging in 2.1. I have 2 times 2.1 plus 5 minus 9 over 16 minus 4 times 2.1 squared, which gives me a negative on top still. I don't know why, I desperately want that to be positive. A negative on top still, but now I have a positive on the bottom, which makes this whole thing, sorry, now I have a negative on the bottom. I can do this. Now I have a negative on the bottom, which makes this whole thing positive. So you can plug that into your calculator and hopefully get it right the first time and not have to say it 3 times like I did. So this on the right side tells me that the limit as x approaches 2 from the right of f of x is going to positive infinity. Note that these are not the same, which tells me that the answer is does not exist because my left and my right sides are different. So there we got does not exist. Note that x equals 2 is therefore an infinite discontinuity over here. Now if you have the regular version, when you plug in, you actually do get 0 over 0, which means that we would rationalize. So I would multiply by 2x plus 5 plus 3 over root 2x plus 5 plus 3. My goal being to eventually cancel out a factor of x minus 2. So this then equals to the limit as x approaches 2 of 2x plus 5 minus 3 squared, so that's minus 9, over 16 minus 4x squared times root 2x plus 5 plus 3. So 5 minus 9 is 4, or negative 4, so we replace that with 2x minus 4. I'm going to factor out a negative 4 on the bottom because I can see that that is my greatest common factor and get that this is x squared minus 4 times root 2x plus 5 plus 3. Sorry, that plus 3 is not under the radical there, so be careful about that. 2x plus 5 plus 3. So now I'm trying to find that x minus 2, so I'm going to finish my factoring the limit as x approaches 2. I factor out a 2 on top to get x minus 2. I already factored out that negative 4 on the bottom. This is now a difference of squares, so that's x minus 2 times x plus 2 times root 2x plus 5 plus 3. And now I can cancel out those x minus 2's, which means that I've canceled out my 0 over 0, and I can plug in again, and I'll get 2 over negative 4 times 4 times root 9 plus 3, so that's 3 plus 3, which is 6, which gives me a negative 1 over 48, and that is my final answer here. So here, in the first one, in the enhanced version, you had an infinite discontinuity. In the regular version, you actually have a removable discontinuity. We didn't get infinity, we got an actual number. All right, let's move on to our last limit here, which, guess what? When we plug in, we actually do get 0 over 0 here. So we need to do something else. We're looking to cancel out our factor of x plus 1. So what do we need to do here? We see that this has a fraction inside of a fraction. So I'm going to do this actually in 2 steps. The limit as x approaches negative 1. I'm going to rewrite it so I have room here. X plus 2, 5 over x plus 2 minus 5 over 3 plus 3 over x. And what I can see is my fractions, I have 1 in the numerator and I have 1 in the denominator. So I need to clear denominators by multiplying by those denominators. First, I'm going to deal with the numerator. So I'm going to multiply by x plus 2 over x plus 2. And note that you can do this all in one go as well. I find it actually a little bit simpler to do it piece by piece. It really doesn't matter though. So here then, I end up with the limit as x approaches negative 1 of 5 minus 5 times x plus 2 over 3 plus 3 over x times x plus 2. Now remember, what we're doing here is we're distributing that to each of the terms in the numerator. I don't need to distribute it in the denominator because there was no fraction with an x plus 2 on the bottom in the denominator. So I can leave that separated like that. So now I'm going to deal with the denominator and I'm going to multiply by x over x. And so this will give me the limit as x approaches negative 1. I'm going to go ahead and simplify the numerator while I'm at this. So I'm going to distribute that negative 5. So here I'll have 5 minus 5x minus 10. Be careful, I'm distributing it to both things, times x. Over, now this x I'm going to distribute into my denominator. So I'll have 3x plus 3 times x plus 2. I don't need to distribute that x and the x plus 2 because this is all multiplication. So if I have like 5 times 3 times 7, I don't need to multiply the 7 by both the 3 and the 5. It only gets multiplied by one of them. So what I did there, it's like saying 5 times 7 times 3. I just moved things around. So I don't need to distribute that 7 into both of those things. I don't need to distribute the x into both of them. So now I'm almost done here. I can see that I'm really close to having my factor of x plus 1. So I have the limit as x approaches negative 1. 5 minus 5x minus 10 becomes minus 5 minus 5x times x over 3x plus 3 times x plus 2. Now on the top, I can factor out a negative 5. And I'll have 1 plus x left over. And on the bottom, I'll factor out my 3. Note that 1 plus x and x plus 1 are the same thing. Order of addition does not matter. 1 plus 2 and 2 plus 1 is the same thing. They are the same thing. So I can cancel out the 1 plus x with the x plus 1. And here I'll have the limit as x approaches negative 1 of negative 5x over 3 times x plus 2. Now I plug in and I get negative 5 times negative 1 over 3 times 1, which leaves me with a positive 5/3 as my final answer. And that is the end of group work 1. That's all. Bye, guys.